Hello everyone and welcome to part 3 of the axial skeleton, where we'll be talking about the vertebral column. We'll see that the vertebral column can be subdivided into a few different parts. We have the cervical vertebra in yellow, the thoracic vertebra in that orange coral color, our lumbar vertebra in red, our sacrum in blue, and the coccyx down there at the bottom in green. Now you will need to know how many of each are in each area. So starting from the top, we see that we have 7 cervical vertebrae. And to name them, we count down from the top. So if we look at this model here, we see that we have C1, 2, 3, 4, 5, 6, and 7. Looking at our thoracic vertebrae, we see that we have 12 of those. And each one will actually correspond to a rib, just like we have 12 ribs. We have 12 thoracic vertebrae. So again, we'll count those with T starting from the top. So T1, T2, T3, going down to T12. Then we have our lumbar vertebrae. We see those in red and we have 5 of those. They're quite big, right? We'll see that they get progressively larger as they go down because they have to bear more weight. So we'll have L1, L2, L3, L4, and L5. Actually, I might as well point this out while we're here. Here we see our sacrum, and this down here, this is our coccyx. Now, you will need to know how many vertebrae are in each section, and there's an easy trick to remember this, and it's times of day that you eat. So we have 7, let's say it this way. We eat at 7 a.m. in the morning for breakfast, so we have 7 cervical vertebrae. We eat lunch at noon, we have 12 thoracic vertebrae. We eat dinner at 5, so we have 5 lumbar vertebrae. We'll also notice that we have certain curvatures to our spine. So if we look at our skeleton here, we see that the spine is curved, right? It's not straight up and down like this pole here. It's curved in and out and in again and out again. And these curves outward correspond with areas where we're gonna have a lot of organs, right? So we want to make room for those organs. So we curve the spine out. But if the whole spine was shaped like that, it would be shaped like a C. We wouldn't distribute our weight very well, and it would be hard to live and walk upright. So we curve inward to make up for it. So the inward curvature will be called a lordosis, and this outward curvature is called a kyphosis. So we have a cervical lordosis, a thoracic kyphosis, a lumbar lordosis, and a sacral kyphosis, curving outward. Now, we also need to be able to identify our various vertebrae and features of each vertebra on its own. So if we start, let's look at this guy here. Okay, so we see that this vertebra has a vertebral body here. So it's this kind of bigger flat part. We see a vertebral body here. And we see a vertebral body here. That one's much smaller. We will see a vertebral foramen This is where the actual spinal cord will pass through, staying nice and protected inside here. And we can actually see that in this model over here, right? This is showing, let's see. That's kind of showing it. You can't see it very well, but you will see that there is a spinal cord that is passing right through there. We will see a transverse process. The transverse processes are going to be these parts that are sticking off of the side here. So right here and right here, they look like little ears. Okay, we also see them here and here. Here, we also see transverse processes. But in this one, we also see something called a transverse foramen. And remember, foramen means hole. So here we see a transverse foramen right here and right there. All right. Now, these transverse foramen, these are identifiable features of one specific type of vertebrae, and that's our cervical vertebrae. We do not see a transverse process in our thoracic vertebra or in our lumbar vertebra. We have this piece that sticks out, this posterior piece here, and that's our spinous process. When you look at the spine, any section of the spine, you will see the spinous processes are posterior and they're sticking out the back here. So when someone sort of bends over, if they're quite thin, you can usually see this poking out of the back. Okay. And then these, the body, right? The body is the more anterior portion. We can also see our intervertebral discs here, those cartilaginous pieces that are going to provide some cushioning. And then finally, you will see that we have superior articular processes. And this is where one vertebra will articulate with the next, right? So you can see that here, how you have one that will sit right on top of the other at the superior articular process. Okay, we see that here as well. And here. Okay. All right. Now let's learn to identify these individually. Now, I already gave you the trick for the cervical vertebra. The first one is it's small, right? So this smaller vertebra will be much easier to identify. All right, now you know which side, by the way, is the superior articular process because the spinous process is going to curve downward like that, just like we see here, right? It isn't flipped up like that, right? It's like this. All right, so look for that. Same thing with these bigger guys here, right? You'll see that spinous process pointing downward. Okay. Now, for our cervical vertebra, we said the body is going to be much smaller. The bone itself is going to be much smaller. We also said we had this very distinctive transverse transverse foramen on either side. So it's that hole in the transverse process, okay, called our transverse foramen. Here we're looking at a thoracic vertebra. And this you can identify by a few things. First of all, it tends to have a quite long spinous process. You see those? Quite long. Compare those to these, right, where they look more short and stumpy, okay? So longer spinous process. We also see that when we hold it by its neck, it kind of looks like a giraffe, right? It has this long neck, these big ears that stick out on the side, right? And this little head, all right? So these longer transverse processes, remember that we will have ribs that will articulate or come off of these, okay? And then here, this looks like a moose head to me, and this is a lumbar vertebrae. So we'll see this sort of shorter and stubbier process here. We'll see a very big body because it needs to bear a lot of weight. And like I said, it kind of looks like a moose to me. All right, so we have our lumbar vertebrae, our thoracic vertebra, and a cervical vertebra. Now, we also need to be able to identify specific vertebra. There's only two that I want you to know by name, and that's our C1, or our atlas, and our C2, or our axis. Okay, now these are very important. The atlas is very important because this is going to articulate with your skull, and we can see that there, right? This is showing the bottom of the skull. Here we're looking at our C1, or our axis, and we can see how it's articulating there. If we look at the actual skull itself, we see that we have these occipital condyles here, and that is where our atlas is going to articulate with our skeleton. Right here. Okay. Now, this is our atlas, and it's named after, so in Greek mythology, we have the Atlas, or the Greek god Atlas, who is going to hold the world, okay? And so this is like your skull, right? Your mind, your head, that is your world, right? All things happen there. So, well, not all things, but you get the point. So the atlas is holding the world, okay? Now, does this have a body? No, it doesn't. Okay, so that's going to be a distinctive feature of the atlas. It does not have a body. Instead, you're going to see that C2, or the axis, is going to, you'll have your atlas that sits on top of the axis. Okay, and I actually have an articulated structure right here. So you can see the atlas here on top, and then you can see the axis beneath it. Okay, and notice that the axis also doesn't have a body, but it has another structure here, and it's this pointy structure, and that's called a dens. Okay, that's a dens. So the atlas will articulate on the axis, and this actually allows it to rotate on its, sorry, I'm trying to do this with one hand, on its axis, like that. Okay. Interesting, right? All right. Now, that is all for our vertebral column, and stand by for part 1 of our appendicular skeleton.